So let's look at Huygens and look at a situation we've seen before where we have a ray coming in, and in this case we're going to look at it as a wavefront, and this wavefront is perpendicular to the ray and till it gets to this transition, and then it's going to bend because we know that the velocity of light in a different medium is slower. So it's going to change, or faster depending on which way it's going. And now we can take and look at some different triangles. So for theta 1 here, this angle, we have the sine of theta 1 is equal to, well, we have BD here. There's one triangle. I mean, one side. We have AD making up the other side, which means we have AB here. And it turns out that these are similar triangles. So this angle here is theta 1. There's a 90-degree here. So now I can say that sine of theta 1 is equal to BD divided by AD. AD is the hypotenuse. But BD is just the distance that the light travels in a certain amount of time. So it's V1 times T divided by AD. Now, sine of theta 2, well, we can see that we have AC and we have AD and we have CD. And this angle is going to be theta 2 due to similar triangles. And that gives us AC divided by AD. So AC here is this this length over here. And AC is just the velocity in medium 2 times the time divided by AD. And now I can take and divide both sides. I can take sine of theta 1 divided by sine of theta 2 is equal to, and I'm just going to divide these over here, V1 times T over AD divided by V2 times T over AD. And this just simplifies down to V1 over V2. But I know that the velocity compared to the speed of light in a medium, well, that's going to be C over N1 for velocity 1, and it's going to be C over N2 for velocity 2. And if I simplify that, I get N2 over N1. And now I can relate these two on the ends, and I get N1 times sine of theta 1 equals N2 sine of theta 2, which means that Huygens is complete. It works with what we know to be true for ray analysis. It also works with wave analysis. So Huygens' principle and Snell's law are agreeable with each other. And remember that the wavelength of the wave in some material N is equal to the wavelength in free space divided by the refractive index. So that works with Huygens also. And so now we can see that the wave nature and the particle nature are actually one and the same.